Imagine a celestial body so humongous, so radiant, that it holds 99.8% of our solar system's mass. A glowing orb of pure energy, a beacon of light and warmth that has been the guiding star for countless civilizations throughout history. This, dear listeners, is the sun, the heart of our solar system, the center of our cosmic neighborhood. From the fiery inferno of its core to the radiant brilliance of its surface, the sun is a marvel of cosmic proportions. Its immense size is truly mind-boggling. It's over 100 times wider than our own planet Earth. But the sun is more than just a giant ball of burning gas. It's the engine that drives our solar system. Its gravitational pull keeps us all in a delicate balance, a cosmic dance around this fiery star. The sun, a colossal sphere of blazing energy, is the heart of our solar system, around which all planets revolve. It's over 100 times wider than Earth, but how does it compare with other stars in the universe? As we delve deeper into our cosmic journey, let's take a moment to reflect on the sheer magnitude of our sun. This fiery celestial body is a colossal sphere of energy, dwarfing every planet in our solar system. Yet when placed on the cosmic scale, it's but a medium-sized star, a modest player in the grand theater of the universe. Consider Betelgeuse, a red supergiant in the constellation Orion. It's so large that if it were at the center of our solar system, its surface would extend beyond the asteroid belt, swallowing Mercury, Venus, Earth, and Mars. Now imagine our sun next to Betelgeuse. It would be no more than a tiny speck of light. On the other hand, let's turn our gaze towards Proxima Centauri, the closest star to our solar system. It's a red dwarf that is only about 1/7 the diameter of our sun. If the sun were a beach ball, Proxima Centauri would be no larger than a golf ball. But size isn't everything in the universe. The sun's energy output is immense. Every second, the sun converts about 4 million tons of its mass into energy. This process, known as nuclear fusion, is equivalent to millions of nuclear bombs exploding every second. And this energy, radiating into space in all directions, is what makes life on Earth possible. In comparison, Betelgeuse, despite being much larger, is nearing the end of its life and has a lower energy output. And Proxima Centauri, while longer-lived, is a faint ember next to the sun's blazing fire, with only a fraction of its energy output. So while our sun may not be the largest star in the universe, its size and energy output are just right for our little corner of the cosmos, providing the warmth and light that sustain life on Earth. Even though it's our closest star, the sun is actually a medium-sized star compared to others in the universe, yet its energy output is immense. At the sun's surface, immense solar flares and sunspots reveal a dynamic living star. This is not a dormant celestial body, but a vibrant, pulsating entity, constantly in motion. The surface of the sun, known as the photosphere, is a roiling sea of plasma, with temperatures reaching about 10,000 degrees Fahrenheit. Imagine a pot of boiling water. Now multiply that energy a millionfold. That's what's happening on the sun's surface every single moment. It's a spectacle of cosmic proportions, a ballet of fire that's both awe-inspiring and humbling. Now let's talk about solar flares. These are sudden, rapid, and intense variations in brightness. They occur when magnetic energy that has built up in the solar atmosphere is suddenly released. Radiating across the electromagnetic spectrum, solar flares can last from minutes to hours, and we can see them here on Earth with the naked eye. And then there are sunspots. They appear as dark patches on the sun's surface. These are cooler areas, still at a scorching 3,700 degrees Celsius, mind you. Sunspots are the visible markers of the sun's magnetic field, which is constantly twisting and flipping. Now let's dive deeper. Beneath this turbulent surface lies the sun's core. Here, in this heart of the sun, a process called nuclear fusion occurs. It's here that hydrogen atoms are compressed under immense pressure and heat till they fuse together to form helium. This process releases vast amounts of energy, equivalent to billions of atomic bombs. This energy then travels outward from the core through the other layers of the sun and finally reaches the surface, before hurtling across the solar system as sunlight. It's this sunlight that warms our world, drives our weather, and supports all life on Earth. In essence, the sun's surface is more than just a celestial spectacle. It's the birthplace of the energy that powers our world. Its core fuses millions of tons of hydrogen every second, releasing the energy that powers life on Earth. The sun's influence extends far beyond its fiery surface. This glowing sphere of hot plasma, our sun, is more than just a celestial body that brings light to our days and warmth to our nights. It plays a pivotal role in shaping our home, the Earth, in ways that are both subtle and profound. Consider this. The sun's energy is the very engine that powers Earth's climate system. It heats our world, creating the conditions necessary for life as we know it. The sun's rays strike the Earth's surface, warming the land, oceans, and atmosphere. This heat energy sets in motion the winds, drives the ocean currents, and fuels the water cycle, which in turn shapes our weather patterns and climate. But the sun's influence isn't just about heat and light. It's also about the fascinating dance of particles that occurs between the sun and Earth. The sun constantly emits a stream of charged particles known as the solar wind. When these particles reach Earth, they interact with our planet's magnetic field, creating spectacular phenomena like the northern and southern lights, also known as auroras. These shimmering curtains of light in the night sky are a visible testament to the sun's influence on Earth. And let's not forget the most crucial aspect of the sun's influence: life itself. Every living thing on Earth, from the smallest microorganism to the largest whale, relies on the sun for survival. Plants use the sun's energy to photosynthesize, converting sunlight into chemical energy. This energy then cascades through the food chain, fueling all life on Earth. In fact, without the sun's energy, life as we know it would cease to exist. So the next time you feel the warmth of the sun on your skin, remember that you're experiencing a tiny fraction of the immense power that shapes our world and sustains life on Earth. Its energy drives our climate, creates mesmerizing auroras, and sustains all life forms on our planet. Humanity's quest to understand the sun has led to groundbreaking missions. We've sent emissaries of science, not human in flesh and bone, but in metal and silicon, to brave the searing heat and radiation of the sun. One of these missions, the Parker Solar Probe, launched in the summer of 2018, is designed to swoop within 4 million miles of the sun's surface, enduring temperatures higher than 1,000 degrees Fahrenheit, to gather data about our star. The Parker Solar Probe, named after solar astrophysicist Eugene Parker, has already made several close approaches to the sun, collecting valuable data and breaking records for the closest any human-made object has ever come to the sun. It's helping us to understand the sun's corona, the outermost part of the star's atmosphere that is strangely hotter than its surface. Then there's the Solar Orbiter, a mission of international collaboration between NASA and the European Space Agency, launched in February 2020. While it doesn't fly as close to the sun as the Parker Solar Probe, the Solar Orbiter's unique orbit allows it to get a first-ever look at the sun's poles. These missions are helping us to understand why the sun's magnetic fields change, leading to periods of solar maximum and minimum. These daring missions, along with others like the Japanese Aerospace Exploration Agency's HINODE and NASA's Solar Dynamics Observatory, have given us unprecedented insights into the sun's behavior and its influence on space weather. They've provided us invaluable data on solar flares and coronal mass ejections, massive bursts of gas and magnetic fields that can disrupt technology on Earth and pose risks to astronauts in space. These missions bring us closer than ever to our star, unraveling its mysteries and protecting our planet from solar storms. As we continue our cosmic journey, we remain in awe of the sun, our source of life and light, and the heart of our solar system. The sun, a source of wonder and the cornerstone of our existence, continues to captivate and inspire. This fiery beacon has been the silent witness to our history, illuminating our paths and shaping the rhythm of our lives. From the break of dawn, painting the sky with hues of orange and pink, to the tranquil descent at dusk, the sun's daily journey has been a constant in an ever-changing world. Its radiant energy not only lights up our day, but also fuels the cycle of life, powering everything from the smallest plant to the mightiest of beasts. It's the ultimate artist, painting the canvas of our planet with diverse climates and seasons. Beyond its physical influence, the sun holds a profound place in our cultures and consciousness, symbolizing hope, warmth, and vitality. Our journey in understanding this magnificent star has only just begun. How do you think our lives would change if the sun's behavior altered dramatically? Thank you for watching. If you enjoyed this video, give it a like. Craving more? Hit subscribe and journey with us through the realm of learning. Remember, every thumbs up and every subscription fuels our passion to deliver more. Become part of our learning community today.